Hello everyone, welcome back. In our previous session, we are having successfully completed our secure calculator tool implementation with AST passing and safe mathematical operations whitelist. Today we will be working on our web search tool implementation, which is going to be a game changer for our personal assistant. We will be working on HTTP request implementation. This is extending our agent's knowledge beyond its training data cutoff, meaning our agent will be able to access current information from the internet that wasn't available during its training. We will be implementing HTTP request handling with proper error management because when we are dealing with external APIs and network requests, things can be going wrong. We will also be setting up network timeout and retry strategies for reliability, ensuring our tool is working consistently even when network conditions are not perfect. Then we will be working on API integration and authentication. We will be implementing API authentication and secure credential handling. This is ensuring that our API keys and credentials are being managed safely. We will be processing the API responses into formats that our agent can be understanding easily, converting raw search results into structured data. This is connecting our agents to the broader digital world and giving them access to current information, breaking the barrier of training data cutoff. This web search tool is going to be transforming our personal assistant from a static knowledge system into a dynamic, current information aware agent that can be searching for real time information on any topic. So, let's be getting started with building this powerful web search capability. First, I am importing the required modules. So, I am importing requests. This is allowing us to make HTTP requests to Search API. Then I'm importing dict and any from typing for our type hints. Next, I am importing our base tool and tool result from our base.tool module. Now I am creating our web search tool class that is inheriting from base tool. First, I am writing the init method. I am calling superinit with name web.search and description. Search the web for current information and answer questions. Now I am importing our config from utils.config inside the method to avoid circular imports, and I am getting the SERPer API key from our configuration. Next, I am implementing the getThatSchema method. This method is returning a JSON schema that is describing our tool's parameters. I am defining that we are expecting a query parameter of type string for the search query and an optional num results parameter of type integer that is defaulting to 5 for the number of search results to return. Now I am implementing the execute method. This method is taking a query string and optional num results parameter and it is returning a tool result. First, I am checking if we have an API key configured. If not, I am returning a tool result with an error message telling the user to add the SERPer API key to their .env file. Now I am wrapping everything in try-catch blocks for proper error handling. I am setting up the API endpoint URL for SERPer, creating headers with our API key and content type, and creating the payload with our query and number of results. I am making the post request using request.post with our URL, JSON payload, headers, and a 10-second timeout. Then I am calling reason for status to ensure the request was successful and I am getting the JSON response data. Now I am formatting the results for better readability. I am creating a results list and iterate through the organic search results from the API response. For each result, I am extracting the title, snippet, and URL. I am also checking for an answer box in the search results. This is when Google provides a direct answer to the query. If everything is successful, I am returning a tool result with success equal to true and detailed data, including the original query, formatted results, answer box if available, and total results count. I am also including metadata with search time and total available results. I am handling specific exceptions. request.exceptions.timeout for when the search request times out, request.exceptions request exception for other HTTP related errors, and a general exception handler for any unexpected errors. This implementation is ensuring that our web search tool can be reliably searching the internet and providing current information to our agent. We are now being done with our web search tool implementation. We are having successfully created a tool that can be searching the internet for current information, handling API authentication, processing responses, and managing errors properly. Now, looking at our tool result standardization, we are actually having already done this in our base tool lab. So we will be marking this as completed. Let me be walking you through where we did it and explain the code. If you are remembering back to our base underscore tool.py file, we are having created our tool result object design. Let me be showing you this code. We are having defined our tool result class that is inheriting from base model. This tool result object is standardizing all tool communication across our entire system. We are having a success field of type Boolean. This is indicating whether the tool execution was successful or not. Then we are having a data field of type any that is defaulting to none. This is containing the actual payload or results from the tool execution. We are also having an error field of type string that is defaulting to none. This is containing user-friendly error messages when something goes wrong. Finally, we are having a metadata field of type dictionary that is defaulting to empty dictionary. This is allowing us to include additional information like search time, total results, or any other relevant metadata. This consistent format is ensuring that our agent brain can be handling results predictably, regardless of which tool type is being used, whether it's our calculator, web search, or any future tools we are adding. We are also having implemented robust error handling framework throughout all our tools. Every tool is returning user-friendly error messages in the same format, enabling consistent user experiences across all tools. This is providing the foundation for reliable multi-tool coordination. So we are having successfully completed our entire tool system development module. So friends, with this, we are being done with module 2, tool system development. We are having successfully implemented our base tool interface, secure calculator tool with AST parsing, web search tool with API integration, and tool result standardization. Our agent now has a solid foundation for working with tools in a standardized, secure, and reliable way. Now, in the next module, that is module 3, we will be implementing agent intelligence, which is the brain implementation of our personal assistant. We will be working on system prompts and personality, where we will be defining how our agent is thinking, responding, and interacting with users in a consistent and helpful manner. Then we will be implementing the React pattern implementation. This is a powerful reasoning pattern that is allowing our agent to think step by step, reason about problems, and act appropriately based on the situation. Next, we will be working on tool orchestration. This is where our agent will be learning how to coordinate and use multiple tools together to solve complex tasks that require different capabilities. Finally, we will be implementing LLM integration, where we will be connecting our agent to large language models and making everything work together seamlessly. This module 3 is being the brain of our personal assistant. It's where all the intelligence, reasoning, and decision making is happening. This is what will be making our agent truly smart and capable of handling complex multi step tasks. So, see you in the next module where you will be building the intelligent core of our personal assistant.